Welcome to the video on Monostable Multivibrator. In this video, I am going to discuss about the concept of collector coupled monostable multivibrator with its output waveform and its applications. First, what is meant by monostable multivibrator? As the name suggests, monostable. In this multivibrator, it has only one stable state, and the other state is called as quasi-stable state or unstable state. So at default, this monostable multivibrator in the stable state. When an external trigger pulse is applied to the circuit goes into quasi-stable state from its normal stable state. So after some time, the circuit automatically return to its stable state. So there is no need to give any external pulse to change from quasi-stable to stable state. So the time interval for the circuit remains in the quasi-stable state is determined by the circuit components and can be designed as per the requirement. So this monostable multivibrator is also called as one shot, single shot or single step multivibrator. And now this is the circuit diagram of collector coupled monostable multivibrator. So here in this diagram, two transistors are used, Q1 and Q2. The two transistors are back to back connected. So this collector coupled monostable multivibrator circuit which uses NPN transistors, right? So this Q1 and this Q2 are identical NPN transistors. So here the collector of Q1 can be given to the base of the Q2, and here the collector of the Q2 can be given input to the base of Q1. So Q1 is transistor 1 and Q2 is transistor 2. Yes, and this RL1 is the load resistance, VCC is the power supply, and this R1 is the resistance. So this R1 and this C1 which is used to determine the pulse width of the monostable multivibrator. And this is the junction of, this is the base junction VB1. Okay, so base voltage of Q1, and this is VB2 base voltage of Q2, and this is VC1 collector voltage of Q1, and this is VC2 collector voltage of Q2. Now this R3 is the resistance which we can give negative bias to keep the Q1 at off condition, and this C2 is a capacitor C2. Here in this place we have to give a trigger pulse to the Q1 transistor Q1. So now we can see the operation. So what is the default state of this monostable multivibrator? At default, at stable state, this Q1 is off condition and this Q2 is on condition. So whenever this Q1 is off condition, so this collector terminal and emitter terminal are open circuited. So this collector current can be 0, and this VC1 voltage at collector, so the voltage, the collector voltage of Q1 equal to this power supply VC2. And what is the status of Q2? Now at the normal, at default, this Q2 is on condition. So the collector current, the collector terminal and this emitter terminal are short circuited. Now this IC current equal to IC saturation, and this VC2 collector voltage of Q2 can be given as VCE saturation. Right? Now, since there is no current in this Q1, we can given this collector terminal to this base of the Q2. Okay. Yes. So now, so after some time, we can at default this Q1 have the negative bias. So this Q1 does not conduct, so it is in the off condition. So after some time, we can give a trigger pulse. A trigger pulse is to change the transition from stable to quasi-stable state. Now you can see what is the condition of quasi-stable state. When the circuits enter into quasi-stable state, Q1 will be on condition and Q2 will be off condition. If Q1 is on, Q2 off means what is the concept of this circuit? If Q1 is on, as it before told that this collector and emitter are short circuited, so the collector current equal to saturation collector current and this Vc1 equal to Vce saturation. If Q2 can be off means what will happen is, so this collector and this emitter terminals are open circuited, so IC equal to 0 and Vc2 equal to this Vcc. So here this graph shows clearly the concept. So 0 is when this is 0, Q1 is off, Q2 is on, and when it is 1, Q1 is on and Q2 is off. So after some time, after some interval of time, again this circuit can be changed into quasi state into stable state. So the time can be determined as this t, that value of t can be given as 0.69 into R1 into C1. So this R and C are the components which determines the duration of the transition. Yes, and this is the working principle of collector coupled monostable multivibrator, and you can see the waveforms. Yes, so based on the conditions we should draw the waveform. So here the waveform have 3 slots. The first is stable. In the stable condition Q1 is off, Q2 is on. In the quasi stable condition Q1 is on, Q2 is off. At stable condition Q1 is off and Q2 is on. And here we are going to draw 4 different graphs. VB2, so voltage at base terminal of Q2, Vc1 collector voltage of Q1, and Vc2 collector voltage of Q2, VB1 base voltage of Q1. So at first condition we can see what is the graph of Vc1. Okay, so Q1 is off and Q2 is on. What will happen is Vc1 equal to Vcc. So now you can see Vc1 equal to Vcc. And in the quasi stable state, what is the condition? Okay, in the quasi stable state Vc1 equal to Vce saturation. Okay, so it will enter into saturation region, so Vce saturation. This is what Vce saturation, and again it goes to Vce saturation from Vcc, right? Let me see the graph of Vc2. So in the first slot Q1 off and Q2 on, so Vc2 can be given as Vce saturation. So now Vc2 is what? Vce saturation, and again it goes to Vcc, and again it comes to Vce saturation. And for now we can discuss about the base voltage of Q2 and Q1. So here again the first condition Q1 off and Q2 on. So in this scenario this VB1 it will initially it will VB2 equal to VB2 saturation, and it comes to some down values, and the capacitor waveform can be generated, and again it ends with the VB2 saturation, the same as for VB1 also. So this is the output waveform of collector coupled monostable multivibrator, and you can see the applications of monostable multivibrator. So the monostable multivibrator is mainly used to produce the rectangular waveforms. Okay, so here hence it is called as gating circuit, and it will be adjustable pulse width generator, and it will adjust the varies the width to uniform width generation. It will generate the clear and sharp pulse from distortion pulse, and also the monostable multivibrator can be used in time delay circuit. Thank you.